What's up, everybody? This is David Angel again. Alright, so today's video is going to be about material and material only, okay? There's a section in the test. When I say the test, I mean like the interview. Uh, Both in the packet, like on paper, where you have the pictures of material with blank spots underneath, and you have to say what it is. Others have, the material there with a bunch of letters and the name of the material beside the letters, and you just match them up. And some have even had the material laid out in real life, so you can actually point to whatever they tell you to point to. If they say, well, point to a 4x4 box, you have to, point out the 4x4 box. Um, so the point is you have to learn the material. You have to learn or get used to the material. Okay, now let me be clear and upfront. You're not going to learn all the material because there's so much, and there's, literally they could bring up random stuff like that isn't as common and stuff. So it's okay if you get to this section and you don't know all of them, but you should know the main ones, and that's the one I'm going to talk about right now. Okay, so we're gonna start with this. Okay, this is an threaded conduit body, but the main, if you ever see something like this, then you're gonna pretty much go to think of LB immediately. Okay, now the LB stands for two things. It's the L is left back. Okay, now the L that stands for left is always going to be there. The B is the one that's going to change. It can be LB, LR, LL. Okay. Now it's not complicated. Okay. Pretty much, you see that there's a circle here, a circle here. This is where the pipe would go in, and this is where another pipe would go in. And then on this side you have like an open. This whole part is open. The point of that is when the pipe goes in here and another pipe goes in here, instead of putting a box so you can pull, if you have really long pulls, you have to put a box. Instead of putting a box, you pretty much pull the wire out through here, make a loop, and then push it in through here into this pipe. The main thing to know here is this is an LB because you have a pipe going straight into it, and then it comes out from the back. You see how it's, like I said, this is open, so that's technically the front. We're looking at it from the side right now. The pipe goes in and it comes out, this part goes out from the back. There's a piece that goes in, it's identical to this, but instead of this going out from the back, you would see a hole right here on this side. Now once again, like I just said, you're looking at it from the side right now. So the front is technically this side right here that you can't see, that has the big hole. So if the hole is on this side, technically, if you're looking at it from the front, from this big opening, this piece is going to be on the right side instead of in the back, on the right side. So it's going to be, this is when it's going to be a LR, left, right. And let's do the opposite. If this part was facing that way, the white space, and you could just see the pipe coming in here, and you wouldn't be able to see, this coming out from the back, or you wouldn't be able to see the hole here coming out from the right, because it'd be on the other side, then that would be a left. So that'd be a LL, okay? The only thing you need to put is LB if it's coming out from the back, LR if it's coming off right here, if you see the hole right here from the right, or a LL if it's coming out from the other side. Alright. I could not find a page with all the material, so I'm just going to go ahead and go through this really quick. I will provide the link to this website. This is where most companies get their material from. So they pretty much have everything here, and I'll provide you the link to the pages that you should look at. Okay. All right. Now, let's see here. I've seen this on tests. This is pretty much metal, and you'll see metal with a lot of lines, and then it's some sort of plastic covering it. If you see something like this, where you know this is bendable, it doesn't have to be straight. If you see something like this, something solid, and then after that it comes out with something with a lot of lines, just put liquid tight. Liquid tight. This liquid tight right there. You don't gotta remember all this, just liquid tight. Okay? Let's see here. If you see just the metal part, this is what was inside of that plastic. Just the metal, like this, a bunch of like lines like that on it. This is gonna be flex or green field. Okay, forget this. Forget that. I know what I'm talking about. I know what I'm telling you. If you see this, and this is bendable too, so it doesn't have to be straight, but the main thing is the ridges here. That's going to be green field or flex, okay? Okay, so I'm going to be skipping, okay, in order to make this video shorter and more easier to watch. I'm just going to find the stuff and then I'll record, okay? This right here is a spring nut, okay? You see how you put a thread in, you can put a threaded rod in here, or you can put a bolt in here, right? So this serves as a nut. Now, the reason this spring is here is so you can use it with this, which is strut, okay? So this is a spring nut. Obviously it has a spring, and I just told you it's a nut. So spring nut. This right here, you'll see it's long, it's metal, it has these oval, or you can have circle holes also, but usually time it's oval like this also, or this also. This is called strut, like this, strut, okay? This is what I was talking about earlier. This is LR, but this is, you can see a little bit better here because it's kind of 3D here. So you can see a pipe goes in here and a pipe goes out there. The one we looked at earlier, this was in the back. That's why I said this is always going to go in through here, always. This is what's going to change. Right here, this is the opening. You look at it from the front. This is on the right side, looking at it from here, right? On the right side of this. So this would be a LR. If this was on the other side, it would be a LL. Left. The L stands for left. The R stands for right. The B stands for back. If this was in the back, like in the first one, that'd be a LB. This is a LR though, okay? And this right here is a pull C. It's similar to this, but since it's just going straight through, it's called a pull C. Okay, here we have a couple of things. This is EMT. This right here is a strap to strap your EMT. This is a 2-hole strap. You won't see many of these. This is a 2-hole strap though. Alright. Then you have this right here. This looks a little bit different because it's for rigid, but this would be a 1-hole strap. Imagine this without this piece. Just this and this loop, and that's it. This isn't there. Just like this, but you know, this vary a little bit. This is a 1-hole strap, okay? That is a 1-hole strap right here. This is a 1-hole strap. This is what I was talking about. 1-hole strap. This right here is a coupling. You see how you put one pipe in here and another one there? That's a coupling. Okay, right here we have the connectors, okay? So let's start with this one right here. This, and it's, you know, it's, I mean, I can't really make this easier for you. You're just gonna have to like really just visualize it and be like, okay, that's what that is. This is a liquid tight connector. You remember what I told you that was like plastic on the outside, metal on the inside? Well, this is the connector for that. This is a liquid tight connector, okay? You'll notice it has the ridges, the lock nut, this little yellow washer there, and then this big thing right here, okay? This right here is a MC connector. You'll notice it because it has a screw right here that you can tighten it once you put it in, and then this little small opening right there. Okay, here, this is a connector right here. You can see the pipe goes in here, and then this is threaded with a lock nut, so you can attach it to a panel or a box, whatever. This is a coupling once again. This is another form of coupling, okay? Then we go down here, that's another form of coupling. It doesn't always have to have these two screws. It can be like this also. That's a coupling. That's the most common type of coupling, actually. You have the LBs that I was talking about there. Okay, this right here is an M. Oh no, this right here is a Romex connector. I'm sorry. You see how it's like it has half an oval right there and then it's flat? That's always going to be a Romex connector. Okay. That's a connector, an EMT connector. This is a rigid coupling. This is a coupling to bring together two pieces of rigid pipe. Rigid pipe, remember, it's the thickest type of conduit there is, and it has ridges, so that's why this has ridges on the inside, so you can thread it onto there. Okay, so now getting into boxes. If you ever see a box like this, and you will on the test, you see how it's square? It has holes in the bottom and the top and the back. But the main thing to notice here is that it's square, and then it has these tabs, but they're all on the inside. This is a weatherproof box. Okay, you'll see it again right here. This is a weatherproof box. Okay, notice that. Alright. Now this right here, this is a regular 4x4 box. It's gonna have a lot of these pretty much, they're called knockouts. So if you want to put a pipe or a connector or whatever, you just push this in, move it around until it loosens up and falls off, and then just stick it in there. Okay, this is the most common box there is. This is a 4x4 box, and once again, notice how it has all of these little knockouts, and notice, just notice how it is. That's a 4x4 box. This right here is a little different because you'll notice that this is a different material. This is a metal box, but it's square and it only has one hole on top, one hole on the bottom. Okay, when you see this box, this means this is a masonry box. Masonry box. This is a box for concrete. Alright? This is a 4x4 box once again. Alright? Okay, this right here is a beam clamp. The most common type of beam clamp is going to look like this. Okay, now there's a lot of different types, but they ultimately are the same thing. They have a bolt that goes up and down, this lip to put under the material, and then you put whatever you want to attach here, and then you just tighten the bolt down. Okay, see how this is the same thing? Bolt and the lip on the bottom. Bolt and the lip on the bottom. There's just different sizes for different purposes, okay? But that's a beam clamp. Okay, now this is the type of receptacles, okay? You have different types of receptacles. They're not all the same. This is the most common right here. Look at where I'm pointing my mouse right here. This is the most common. This is also common, but not as much. Alright, this is what you see in most houses, right? Well, this one right here, that one doesn't have a ground. But this right here is what you see in most houses. This is a regular receptacle. If you see this, just put regular 120 volt receptacle or just regular receptacle. Now, if you see this one that's square like this, well, I'll show you a better one. If you see one like this is square and it has two buttons in the center. You find these in kitchens, you find this in bathrooms, you find it in any location where there could be something, it could be a damp or wet location, because this has a GFCI built into it, okay? People call it GFI, but it's technically the proper name is GFCI. Now, GFCI stands for Ground Fault Circuit Interrupter. Okay, that might be a question. Probably not, but I have seen it. A GFI is this type of receptacle, okay? And it's called a GFCI because it's a Ground Fault Circuit Interrupter. The point is, if you have something plugged into this, like a let's say a blow dryer, plugged into this in the bathroom, and then it falls into a bathtub full of water and there's somebody in there. If this was not a GFCI protected receptacle, that person would get shocked, probably die, right? That's what you see in the movies, blah blah blah. However, if you plug it into a receptacle that's GFCI like this, because it's square and it has the two buttons there, then no matter what happens, if you cut the wires or whatever, as soon as it notices something is not right, this thing will trip the breaker and they will turn the power off before anything bad can happen, okay? That's why you only find it in wet locations. This right here is a 240 volt receptacle. This is mainly for dryers, stoves, things like that. Or this one right here, like this black one that has 3 prongs. That's what I meant, not this one, I'm sorry. What I meant was this type of receptacle right here. They're circles and they have kind of like the little prongs are in a circular shape. Alright, those are for dryers, stoves, and those are 240 volt receptacle. Remember, 240 would be considered high voltage. So okay, I've seen this on test too, and it pretty much looks like this right here. 2 big light bulbs from a little base, okay? It can look like this, like this, like this, like this, okay? If you see something like this, these are called emergency lights or flood lights, okay? I've seen that on test. And then something like this would obviously be an exit sign, okay? Exit light, I mean. This, like I said in another video, this is a can light, okay? They can look like this. This is the whole thing from the top. That's another version of it. This is a can light or recessed light, alright? Okay, this right here is 2 different types of switches, okay? Single pole switch is when there's only one switch controlling that light. For example, in your room, you have a single pole switch unless you have 2 entryways and therefore 2 switches to control the same light. If you have 2 switches controlling the same light, then you have a 3-way switch, okay? Now this is still, like, you know, identifying them. So a single pole switch is only going to have 3 screws, okay? Like here you can see it has a ground screw and 2 gold screws. And the point is it only has 3 screws. A three-way switch is going to have 4 screws, okay? It's going to have 2 on the top, 2 on the bottom. Remember that, okay? Now I do want to mention this really quick. This isn't something that they don't always ask you this as a helper, but it's good to know, and pretty much is how a switch is wired up with a light, okay? Now let's go over here, and I'll explain it really quickly, really briefly, because I don't want to, you know, complicate things. I don't want to confuse you. Let's just look at this one right here. Let's say that actually, let's do a single pole switch. It's the easiest one, so obviously that's where we should start, huh? Okay, so whatever. I'm just gonna use this as an example. Let's say that there's only one switch here, okay? There's a light bulb and one switch. This is, make this disappear. Like I said in the previous video, for one circuit you need 3 wires. 3 wires. You need your ground, your neutral, and your hot. Remember that? Okay, so pretty much any time that you're going from one place A to point B, you're gonna be feeding it electricity, right? Obviously. So how are you gonna be doing that? With one circuit. So anytime you're going from point A to point B, you're always gonna have 3 wires, whether it's you know, inside of a pipe, inside conduit, or whatever. So let's say that the power source is right here. From this power source, like the panel, you're gonna bring out a circuit feeding this whole little light bulb system, right? Otherwise it won't be able to turn on. I want to make it as simple as possible. If they ask you how do you wire up a light and a switch, This is the simplest way, okay? Without getting complicated, because if they don't ask you, then I don't want to confuse you. The point is, you need a ground in everything like I stated. So let's say that the panel is here. You need to bring a ground from your panel to your switch. Then from your switch to your light. Okay? That ground is going from your panel to your switch, from your switch to the light, so your light can have a ground, your switch can have a ground, and your panel is obviously going to have a ground. Now let's go with the neutral. The neutral is never needed inside of a switch, okay? The switch is never going to use a neutral. Therefore, if you have a little diagram or whatever, they ask you, do we bring the neutral to the switch? Always say no. A switch is never going to use a neutral. A neutral is also called a grounded conductor, and it's the white or gray wire. It's never going to come to the switch, or it's never going to be used on the switch, okay? So from the panel, if you have a neutral, you can either just skip the switch and go straight to the light, or you can pass, if you have to, you can pass through the switch, but you're not going to connect it on the switch. You're just going to pass through it into the box for the light. Okay, the neutral is only connected to the light. Now, that leaves one wire left, your hot. Your hot is always going to go to your first switch, okay? Remember that. No matter what, there's going to be a ground in every device. Every stop point, there's always going to be a ground. That's the green wire. The neutral is never going to be needed for a switch, so never bring a neutral to a switch. Okay? Unless you're going to say, oh, we're just passing through it, but that's it. The neutral is always going to go straight to the light. Okay? And then the hot wire is always going to go straight to the switch. It's not going to go to the light. It's not going to go anywhere else but the first switch. And I say the first in case later on, you know, I start talking about 2, 3, 4, 5 switches that you can do. The hot coming from the panel or your home run is meaning what's, you know, where the power is coming from. The hot coming from there is always going to go to your first switch, and then it's going to attach to one of the screws on the switch. Then from this switch, well, I'm going to introduce you to this other type of wire. It's not other type of wire. It's the only reason that they call it something different is because it's the one feeding the light. Okay, so the hot wire is going from your power source to your switch, and then from your switch is going into one of the screws. From the other screw, remember we said a single pole has 3 screws, one for the ground, one for the hot, and then one for the switch leg. One for the switch leg. The switch leg, that's what it's called. It's a switch leg because it's going to be on a switch only. It's never going to be used on a receptacle, nothing like that. It's always going to come out of a switch. That's why it's called a switch leg, because it's going to be taking up the 3rd screw. That wire is going to go from this 3rd screw going all the way to the light, and that's what's going to bring power to the light. Okay, the screw that has the power from the home run is never going to go to the light, always going to go to the first switch, and then on the other screw you're going to have a wire coming out called a switch leg going to the light, feeding the light. That's as simple as I can say it, okay? And that's really all the material. There might be some more material, but it's very uncommon, things like that, so don't worry about missing it. But that's it for this video. That's all the material, and that's pretty much all the things that you're going to need to learn, okay? The next video that I'm going to make is really just going to be talking about the actual process, you know, what you need to expect or what you should expect and things like that, okay? As far as everything like what they might ask you, I have taught it to you now. I'm also going to be making a video on the on the tools that you're going to need, the basic tools that you're going to need. I'm not going to make you buy anything that you don't need, but you do need all these basic things when you go out to the job site in order to be you know, in order to not get fired. So that's it for this video, you guys. I'll see you guys on the next one.